Okay, so we are recording now. So welcome everyone to this workshop on microservices, Docker, and containers. This is in line with basically this topic, the Microsoft Docker containers, and you can also extend that to Kubernetes, mostly for the performance engineers, site reliability engineers, prospects, and performance architects. Though those are working into the microservices container world and looking into these applications. So mostly this is going to help them. Okay, this particular workshop. Okay, so I believe most of us who have joined here are performance testers, engineers, or kind of SRE prospects. I just would like to know in the quick chat if you could just give me a one liner uh, of your experience, guys, or what domain you are from, so that we can just take this forward. Okay. While you do, let me introduce myself. Okay. So, my name is Roshan, everyone. I have around 16 years of experience in IT. Currently, I am working as a principal SRE with one of the retail giants. I take care of their availability, reliability, high availability in production. So I make sure that the application is highly available and robust, reliable, highly performing, secure. So I take care of those aspects. So I'm mostly into the performance side and on the production, looking into the reliability part of it. But I started my career as a Java developer, and been into Python now. Mostly I'm working into Python scripting, Python automation now. I'm a multi-cloud associate architect certified, AWS, Azure, GCP, OCI, Oracle Cloud Infrastructure. Uh, been into automation into various tools that we have in DevOps, be it Ansible, Terraform, right? So completely into Kubernetes, working into Kubernetes architecture, microservices. Uh, on my passion, guys, I love to share my knowledge. I love traveling. I just need to share the teaching is one of the passion I just encountered, like found 6 years back. I was helping others in my team members. So from there I got this interest of sharing knowledge, and since then I have been a part-time trainer. I like to share my knowledge in various platforms. Okay, so that's a background about me, guys. I am teaching from last 6 years. That's my teaching credentials. Okay, I do see Anup replying. Okay, 7 years BFSI domain, real time browser performance testing on .NET applications. Good to know, Anup. So, just guys, quickly help me understand your background in one liner. That would be enough. Uh, okay, Rahul, 10 years, 10 plus performance testing engineer. Good to know, Rahul. Welcome, Anup. Rahul, uh, there's deep 13 years of experience, performance management from 6 years. Good. Sasank, 4.5 years from performance engineering. Good. So I do see most of folks are from the performance background. I love this field. Okay, I love this domain because there's no limit of learning here. A performance engineer cannot say that I know enough. That's one of the joke with performance engineers, that we are not DBAs, but we need to know how to tune database. We are not a developer, but we need to optimize the code. We are not architect, but we need to suggest solutions so that the applications are reliable, highly available, right? So we need to take care of those aspects, right? So we need to wear multiple hats. Okay, so that's what as performance engineers, our roles and responsibilities are. Just can you give me a minute. Hey guys, good. So I do see a lot of messages from Arpit, 9 years, performance engineering lead. Good to know. Arpit, welcome. Rupa, 10 plus years, performance testing and engineering. Good. Welcome, Rupa. Satish, 8 plus years. Good. So see guys, most of us from the performance background. Good. Welcome everyone. So this is going to be the agenda for today's workshop. Okay. So we will understand. Uh, okay. I request everyone to be on mute and you can unmute your question. Okay, no problem with that, but please be when I'm speaking. Thank you so much, guys. Okay, can I? I'm getting background voice. Ranjit, can you do that, please? Thank you. Okay, so this is going to be the agenda for the today's workshop. We'll understand what is monolithic applications and how different it is from microservices. That's a very important understanding because the entire world, the entire IT industry is shifting towards microservices, and there's a reason for it. Okay, because the high availability concept of highly available concept, it's very much in line with the microservice architecture. We'll understand that how. Okay, so and we'll look into VMs and containers, how VMs, what is the difference between VMs and containers, and where should we deploy the monolithic application, where should we deploy the microservices. We'll look into that. We'll look into container architecture. We'll look into how do we create containers. We'll look into Docker, Docker container lifecycle, installation, and various operations as and when. So there are a lot of agenda, but let's see how much we can cover in this. Okay. So before I get started, I just want to know, understand from you, anyone, if you know, what is monolithic applications according to you? What do we see when I say a monolithic applications? Anyone who has been working on microservices, monolithic application can help me understand that. Okay, no problem. Let me put that perspective. Okay, so when I say monolithic, if you look at the dictionary, the literal meaning of monolithic, it's called big, single entity. Okay, a large unit. So consider an application. Okay, I'm talking about the application server because that's where the business logic resides. So let's say if I have a three-tier application, let's assume. Okay, so let's say I have a three-tier application. Let's say I have a web server, and let's say I have a application server, and let's say I have a DB server. Consider three-tier application, normal three-tier application. And let's focus your thoughts on the application servers. Okay. So let's focus on the application servers. Okay. So when I say monolithic applications, so let's say this application server has got multiple modules. Okay. Let's say consider an e-library application. In e-library application, what all modules could be there? Let's say any application, Flipkart or Make My Trip, any application, there are many modules, right? A payments module, a user inventory module, right? The finance module, HR module. There are many modules that make up one application basically. Let's say, for example, let's just assume that there are 4 modules. Just imagine that there are 4 modules, M1, different modules, M2, okay, and let's say M3, and let's say M4. There are 4 modules. Just take that. So what happens in monolithic applications and how different it is from microservices? To understand that, we need to understand that the code level. Okay. So let me use the, okay. So let's say they are module level. Okay. So let me call this M1. Okay. And let me call this M2. This is M3. And let's say this is M4. Just imagine. Okay. M4. So, and you have been writing functions. You have been writing functions for all these modules, right? Because that's what comprises what these modules have, the functions, the code. Let's say you have been writing a lot of functions. Okay. In M1, just imagine that you have got F1 to F50, 50 functions. Just imagine that you have got 50 functions in M1. Similarly, to that, you have got 50 functions. Let's say this guy has F1 to F50. Let's say that. And let's say this guy is having F51 to F120 functions. This guy is having F121 to F250 functions. And let's say this is having 250 functions. Let's say you have been writing functions. All these modules is having the functions. When you call the functions anywhere and everywhere across the modules, because you remember, if you have been working into the Java project, how you create, you start with the Java project, let's say Eclipse or IntelliJ. How you start with a Java project, right? You start with that, and then you create a Java project, and then you create multiple packages. Inside that, you create classes. In classes, you have the methods. Mostly, that's how you write a programming. Any programming language, not just the Java, but any programming language. You need to follow a structure, right? And all these modules are nothing but the packages, different packages, and you have classes and functions being written. And when you call the functions anywhere and everywhere across the modules, there's a huge dependency across all the modules. And we call it tightly coupled. The word we use, the word that we use is the tightly coupled in case of monolithic applications. So we call it there a huge dependency across all the modules. Because the functions are being called anywhere and everywhere, there's a huge dependency. The issue with one of the function can bring the entire application down, because you all the code are built together. You get one jar file. You have so many functions, but someone has to build. Let's say developer had written the code and he has to build the code. So let's say this programming language in Java, so you get a jar file or a war file, an ER file, which you will deploy on the application server and have the application up and running. So when you build the code, you get only one jar file, because that's how the monolithic application, you get one jar file or a war file or an ER file. You get one jar file. Oh, because tightly coupled, you can deploy, you can build together. That's how it is, right? So that this kind of applications basically are called monolithic applications. Monolithic applications. So the problem with this, right? We all have been working on the monolithic applications. The problem with this kind of application is that the issue with one of the functions can bring the entire application down, because the functions are being called anywhere and everywhere. The function which is for M1 has been called in M2, M3, M4, right? The functions are being called anywhere and everywhere. So huge dependency. The issue with one of this, even the smallest function can bring the entire application down. So it is a threat to your high availability. Because in production, you don't want, see, in production, what is my end goal? Understand this. What is my end goal? End goal is very simple. I want customer experience is the prime for me. For the customer experience is the primest, is the most important factor. And when it comes to customer experience, performance, everything comes into picture. Security, it has to be secure. The user details that you have in the application has to be highly available. You don't want downtime. If Amazon.com goes or Flipkart.com it goes down, you don't like it. You will not. They will lose the business. Reliability, even if they have some issues internally, if they have some issues, some nodes going down, they should not be down and they should recover. So should be highly performing. Security, high availability, reliability, and cost. I can design a solution, but if it is not cost optimized, it's not going to benefit, right? So cost should be cost optimized solution. These are the very important things in any architecture. We need to always consider these are the pillars, and that's what leads to the better customer experience. Everything's put together. It's not like only performance. If it is application is not secure, not good, right? If it's okay, performance wise it's good, but it's not available. Most of the time the server is down. the site is down. Who would go and take a risk in putting some orders, right? The design that you have given is very costly. It's like so costly that client has to put money, is not having the earnings, the margins is not there. It is so much costly architecture, so it's not benefit, right? So the monolithic applications causes the way it's architected, it is the risk in the high availability, because the issue with one of the functions can bring the entire application down, and you have to build the entire code at once. If you have found some bug, let's say you raise some defects in some functions, developer has fixed few functions, but you have to wait for the quarterly release for the entire code to get deployed. You have to wait for it. Quarterly release we do, because you cannot deploy often. You cannot bring the changes to the production. See, what is the end goal? As soon as the developer fixes a code, fixes a bug, I want that change to reflect in production at the earliest. But if such a big code is there, it takes some time to build it. It's a massive process. Everyone will be scared in the organization to build this code just for that small bug fix. So we wait for the quarterly release to happen, and that's how we release things. Now, one of the major things about the scalability. Scalability, let's say you have run a performance test for all the transactions for all these modules, and you observe that in M3, there is a high response time, and when you looked into that, you observed that it is because of the CPU is the contention. You need more CPU. So tell me one thing. We all are performance engineers, 10 years, 8 years experience. Tell me one thing. If I have CPU contention is for one of the transactions, can I scale up just M3? Just can I scale up just for the M3 resource? Or I have to scale up the entire application stack itself? Because all are deployed together, others are performing fine, but one of the transactions is having some issues. M3, one of the transactions, which is from M3 module, I cannot scale that particular module on the infra side. I have to increase the complete application stack, application server infra. So again, that's also a demerit. Again, I will end up having wastage, right? So this is the setup in monolithic applications. So how do we solve that? To solving, we need to understand the microservices, and that's where the world is going. So the best thing is to separate this out. What is the best way solution on this? How can we best possible solution? So one of the best solution is to that you have 4 modules. Good. Take the 4 modules. And can you make it independent? Can you make it independent? That's the question. That you don't call the functions, make it independent and self-sufficient. Don't call the functions directly. Whatever the functions you have been writing, make sure you don't have the functional dependency. Whatever the functions you have been writing, whatever the functions are, don't call the functions. Make it independent. And so that what will happen, you can deploy, you can build and deploy separately. Let's say if all are written in Java, you get 4 jar files for each of these modules. You can deploy, build and deploy separately. If the issue is with M1, you will fix M1 module. You don't have to touch other modules. You can just focus on M1, bring your updates, code. Developer can fix the code in M1 and can deploy. Can be up and running. It's easy, lightweight. It's not like a full heavy application that needs to get built for even for the smallest bug fix. So I'm not calling the function. So if M1 needs some information from M2, how they would get? Through REST API. I will expose the RESTful endpoint. How make my trip calls Indigo, Air India, Air Asia? How make my trip? I go to the online application, make my trip. But make my trip has information about other websites, other flight carriers, how they have. Do they have their database? Does make my trip have the database access of all the flight carriers? No, it's all about the API call. So Make My Trip makes a call to API. They have exposed Indigo, AirAsia, all these flight carriers, they have exposed the RESTful endpoint. So Make My Trip knows if you want to get the flight details, call this API, get call, with details of from source and destination with the date, and it will filter out, get the response. So that's how the microservices communicate with each other. So I will expose the RESTful endpoint. If M1 needs information from M2, I'll call the RESTful endpoint and get the information. Same thing for other modules. Okay, now, so I am creating microservices, right? So now I also get one more thing. I get technology freedom. Earlier, since I was writing the functions modules where the codes were being called anywhere and everywhere, so there was obligation for me to develop other modules in the same technology, same language. But now, since I'm communicating with other modules through API calls, I can have M1 written in Java, I can have M2 written in Go, I can have M4 written in Python, I can have M3 written in Node.js. At the I'm not calling the functions, right? I'm exposing the RESTful endpoint that can be done in any language. So I can select the best language, the optimized language which suits my requirement. Now, earlier there was issue with M3. Earlier there was issue with M3, so I could not scale up just the M3 infra. But if the issue is with M3, since M3 is deployed separately, I can scale up separately. I can just scale up just the M3 resource wherever the M3 is deployed. I can just scale up that infra of M3. Possible or not? Possible or not, guys?
Yes, possible.
Yes, possible. Advantages. Advantages. Issue with M1 will not bring my other applications down. It is as good as if you have a Swiggy application or Uber application in your mobile. If I say, if a notification which comes at which is at the right top corner at the notification one of the module, if I tell you if a notification is not working, you will not be able to book your cab or order your food. It doesn't make any sense, right? It should not impact my other modules. That's what will happen in the microservice architecture. So many advantages of microservices. That's why it's gaining popularity, because the HA is in the architecture. That's the first sentence I made. Remember, I told the HA, high availability, is in the architecture. The way microservices are designed, architected, HA gives HA, high availability. If M1 has some issues, it's not going to impact M2, M3, M4. My entire application will not go down. It can happen that one of the modules may go down, but there are so many other ways to make it highly available. But it's not going to impact. Even if I have one instance of M1, M2, M3, M4, if M1 has some issue, it's not going to impact M2, M3, M4. A lot of advantages, right? But the question comes, where should we deploy this? The question comes, where should we deploy the microservices and where should we deploy the monolithic applications? That's the golden question. That's the golden question. Where should we deploy this? So we have a concept of VM, virtual machine. So we know we have been deploying our monolithic application into VMs. But over the years, it was found that we are not able to utilize the resource of a VM. You need to understand the story, right? So back in 1970s, when there was no virtualization, what was the setup? People were developing applications and they were directly deploying on the physical server. Directly on the physical server. because there were no virtualization, there was no concept of VM, virtual machine, back in 1970s and 80s when the software development started directly on the physical server. We used to waste a lot of resources. It used to be have huge capacity, and there were few KBs and MBs applications which was deployed, and we wasted a lot of resources. So around 1990s, virtualization came, and then we created the VMs, virtual machines. We have hypervisor, we have VMware, virtualized software, we have Oracle VirtualBox, so many virtualized software, and we could create VMs. We installed on these physical servers, we installed something called virtualized software like hypervisor. And after we installed, we could create VMs, multiple VMs of different shapes and sizes. Right now, you can go to AWS and create, or any cloud service provider, you can create VMs, EC2 instances of various shapes and sizes, 1 core, 2 core, 5 core. It's only possible because you have this virtualization done. If it is not about virtualization, you cannot create VMs. You cannot customize your VMs in the cloud. You cannot just do that. Not possible. Different shapes and sizes. You can create multiple VMs. VM1, VM2, VM3, VM4, VM5. Multiple VMs you could create from the same physical server. Which VM1, VM2, VM3, VM4, multiple VMs from the same physical server, from the same hardware. You could create multiple VMs and you can deploy multiple applications. But again, it was observed that over the years that we are not utilizing the resource of a VM. Mostly the VMs are 20 to 30% utilized. That's all. Again, so how to make the utilization of a VM better? And we had this microservices. Can we deploy this? Now this is smaller. It is full applications. It is smaller. I cannot just deploy microservices on the VM. Again, it will have unutilized resource. So back in 2015, not so long ago, one of the company, Docker Inc. is the company name. Docker Inc. Very popular company. Docker Inc. The Docker Inc. Okay. Docker Inc. company introduced a technology called container technology. What they claim that in one VM, I will install something called container engine. In one VM, I will take one VM. What they mentioned that in one VM, I will install something called container engine. I will install something called container engine. And you can create multiple containers. What will I install? Container engine. Like Docker. Docker is one of the container engine. Very popular. And you can create containers. Multiple containers in the same VM. So what does that mean? Let's say this means that if you require 3 VMs to run your 3-tier application, let's say one VM for app server, one VM for web server, one VM for database server. Let's say that you require 3 VMs to run your 3-tier application. What they told, what they mentioned, what the technology claimed, that when you install a container engine on a VM, you can create 3 containers. You can create 3 containers. Container 1 can run your web server. Container 2 can run your app server. And container 3 can run your database server. Wow. In one VM itself, you can have a 3-tier application. Wow. In one VM itself, you can have a web server, app server, and DB server. Wow. So by this, what happened? You can utilize the resource completely. And if you require more resources for your app server or web server, you can have more instances in the other VMs. So at the end, you will be able to utilize the resource better. See, cost is at the center of everything. And in production, the major cost is incurred by the VMs. 90% of the cost, the production cost. So many servers are deployed, 500,000 servers are deployed in production, depending on the scale of the application. 90% of the cost is incurred by the VM. And if I can do this, if I can make the utilization better, it's a great revolution. I can directly save the cost 50 by 50% without impacting the performance. And now, since I have broken down this container using this container technology containers, the microservices are the ideal choice to deploy on the containers. Yes or no? Because microservices are also sub application, subset of the main application, smaller code base, and I can break the VM into multiple containers. So why not deploy the microservice on the containers? That complete the full cycle, and that's why you hear this buzzword Docker, Kubernetes, because in the end they're deploying microservices on the containers, and they're saving a lot of resources, a lot of compute power in production. A lot of saving because of this technology. Nice little story. Everyone is on the same page. Please give me a thumbs up, guys, in the chat window. Yes, no. If you have any follow-up questions on this, because that's very important understanding that we just in last half an hour we have discussed very important. Are we on the same page, everyone?
Roshan, hello, Roshan. This is Darshdeep.
Go ahead.
I have a small question. Actually, okay, you mentioned about containers, like we can deploy containers in the VMs. It can improve the utilization.
Yeah.
But still, can you please maybe repeat what exactly is a container? Like if in few sentences, like not full details, but
Okay,
exactly what is a
in
container?
the layman term. Okay, I believe in the layman term. Okay, I believe in the layman term. Consider containers are like a process. I have a laptop right now. I have opened a Paint application. Correct. I have opened a Paint application. I have opened a GoToMeeting. I have opened a Word document. I have opened Google Slides. I am using some process. These are nothing but the process for my operating system. Yes, these are nothing but the process. If I just show you my task manager, this is nothing but the process running and in my VM. So containers are like a process in the operating system. It's a small world in the big world. So big world is your operating system, and they're using, so like process, how these processes are consuming some resources, some memory, some disk, whatever. They have some, these processes which are running have some footprint. Similarly, containers will occupy some footprint in my OS. They will share some resources. It's like a, how do you do, it's like a virtualization in the same OS. I'll explain this better. Okay. So, how containers are designed. This is what the slide you need to understand this. So, let's understand this. So, in the VM, I am showing you that this is my VM. So, this is my physical server. This is my physical server. I have installed something called virtualization software. Could be hypervisor, could be VMware, could be like a lot of virtual box, could be Hyper-V, any virtualized software. Once I do that, I can create VMs. This is my VM1, this is my VM2, this is my VM3. All the VMs has a guest operating system. Yes or no? Whenever you go to create a VM, you always have a guest operating system. That's why you create a VM. No. What I'm telling, take one VM. Take one VM. This is the infra of one VM. You have the host operating system, which is same as guest operating system. Install a container engine on top of it. Install a container engine on top of it. And all I'm saying that you can create containers, multiple containers in that. But the best part, what is the best part that you should notice? The hypervisor, the virtualization software, virtualize your hardware in the VM, in the VM world. This is your VM, this is your container. Understand this. In the VM world, your hypervisor, your virtualization software, virtualize your physical server. That is why you can create multiple physical servers. Because it virtualizes the physical server, that's why you can create multiple physical servers. Now, what is this container technology? What are you virtualizing? You are virtualizing the OS, my dear. You are virtualizing the OS. So, you can create multiple containers, and all the containers, since you are virtualizing the OS, the containers will feel that they have their own separate OS. They have their own little world, because they will use the binaries and libraries of the host operating system, and they will create a world of their own. I will show you hands-on, guys. I will show you right now this demo. Then you will understand this better. But just try to understand this. There's a difference in the technology itself. The VMs virtualize the physical server, but the containers virtualize the host OS. That's the difference. That's the major difference. You don't require a separate operating system for the containers. You can have one container run your web server, another app server, another database server, or microservices. Microservices 1, microservices 2, microservices 3. It will run as a separate entity, because they will all feel that they are into a separate OS, because they have virtualized the OS of the host. I will show you. So have this thought, okay? Just have this thought with you, and the smallest doubt will be cleared in few minutes. Okay, what I'm going to do, I'm going to create a VM. I'm going to go to the cloud. Okay, I'm going to create a VM quickly. Okay, so let me create a EC2 instance. So that's the cloud, guys, AWS cloud. And I'm just getting a VM because the virtualization has been done by the AWS guys. They have done the virtualization. That is why I'm able to create a VM. Understand this. So I'm able to create a VM, virtual machine, server of my own operating system, where this is the guest operating system. Any operating system I can select: Mac, Windows, Red Hat. I select Ubuntu. I can select the core here, 1 vCPU, 1 GB RAM, just to be free tier, but I can select 4 vCPU, 8 vCPU. I have all the options. I need to pay accordingly. 8 vCPU, 30 GB RAM, I can use it. But let's say I want to be free tier. I will just use 1 vCPU, 1 GB RAM. Basic 1 vCPU, 1 GB RAM. Your laptop has more cores and RAM. This is going to be a very small VM. I can create a key pair. Let me use an existing key pair. Whatever key pair I have, I will create a key pair. Okay. Let me create a key pair. So that we need to log in, right? We need to log in, we need to connect. So I'm creating a key pair. Let's say is workshop. Okay. March. Fine. I will create a key pair. Let's say PEM format. I'm fine. Create a key pair. I will log in using this. So I got the PEM format. And that's the network, because I'm in the Mumbai region. They have all the regions, so I'm using the Mumbai region. So this is the network part. So create a security group. Let's create a security group because you need to have the permission in the VM. It's like a firewall. It's like a firewall for a VM. So I am telling allow SSH. So at least do a, it's a Linux VM. So I want to do SSH to connect. If it's Windows, RDP, right? So SSH happens on port 22, RDP happens on port 3389. So I am allowing, if I have some web application running, I will allow this too also. Fine. 8 GB of disk I'm getting. Okay. That's all. Just let me launch the EC2 instance. I'm creating a VM, very simple VM, one VCP, 1 GB RAM. That's all. And let me name this I can name this VM. If I want, I can just name this VM some works, any name, server one or just give it. No problem. The instance ID is the most important factor here. Okay. So this is coming up. I can use that I have many client to connect. I can use PuTTY. I can use MobiXterm. I can use Instance Connect also. I can use Instance Connect. AWS provides Instance Connect. That's the easiest format. I can quickly connect to this guy through Instance Connect. There are multiple ways. So I will use Instance Connect, but it will help me connect to directly in the browser itself. But I can use PuTTY, MobiXterm. There are so many things I can use it. Is it visible? Is it visible? Is my screen visible?
Yes.
Okay, perfect.
Yes.
Perfect. So I can be a root user. Okay, I can be a root user. Let me update the pack. How do you Windows update? I'm going to do the same thing. Apt update. Since it's Ubuntu, if this would be Red Hat or CentOS, Red Hat or Amazon Linux 2, I would have done yum update. Okay, it depends on the package manager. My command of updating the operating system will change. Okay, I've updated it. Okay, so what will I install now? I will install Docker. I will install a container engine. That's what I told, right? What will I install? Remember the diagram? What will I install on top of this? Docker. So let me install a Docker. So apt install docker.io. I can install a Docker like this. So I'm installing Docker, which is nothing but the container engine. So now I can create containers in the same VM. So if I type Docker version, Docker install. So Docker has this architecture of client and the server. So the way Docker works, that you need to have the image. It needs the image. When all the microservices are in the form of image. Okay, and this Docker Inc. has this website called hub.docker.com. All the major companies, they host their image here, microservices image here. It's a web server. With a web server, HTTPD. This is from the Apache. It's a popular web server, and this is the official Docker official image from the Apache, and I can get the image like this. Docker pull I do. So the way you need to create a container, you need to understand the Docker container lifecycle. Okay, when you can understand the Docker container lifecycle, this is the thing. So I have installed Docker. I have the Docker engine with me. I have the Docker client and the engine. So I will pull the image from hub.docker.com. If I have my own microservices, I can build my own image also. And I can create a repository, like how we create a repository in GitHub. I can create a repository in the Docker Hub, and I can move my image there, and I can pull the image, or I can push the image. So I'll pull the image right now, whatever the images that I have, and I get the Docker images, and when I run this image, it becomes container for me. That's the process, Docker container lifecycle. So what will I do? I will do Docker pull any image. I can do MySQL, I can do Tomcat, I can do Jenkins, I can do MongoDB. Whatever the image I have, I can do it. I have a lot of images. In the hub.docker.com, I have a lot of images. I have Tomcat also. All the official images. I have Tomcat image also. Official. I have MySQL also. I have MongoDB also. I have Kafka also. Like a lot of images. Let's say, let me take one. I have operating system also. Fedora. Operating system are also in the form of image. I can run an operating system as a container on top of a VM, in a VM. Trust me, I can show you. And you will see the size it takes. Because understand one thing that you need to understand, very important, that you are virtualizing the host OS. Even if you run one operating system as a container, both are Linux only. So the binaries and the libraries are common. Since you're virtualizing it, you can use it. What is the significance of virtualizing? You can use it. You can leverage it for the containers. All the containers can leverage it. That is what the benefit of virtualizing the host OS. So I can have different images. So let's say, let's say web server. I want to run a web server. Okay, let's start with that. Web server. HTTPD is the web server I want to. You could have directly installed the web server. apt install Apache 2. I can directly install a web server on this VM. I could have done that. That will run on port 80. apt install Apache 2. If I execute this command, that will install a web server. But that will install on a VM, not as a container. There's a difference. There's a difference. So I'm going to run as a container. So I have to install a container engine. For if I have to directly install a software on a VM, I don't need Docker. I don't need a container engine like Docker. I can directly install apt install Apache 2-y. It will install the web server here. But if I want to run as a container, you need a container engine like Docker. So let me pull it. So right now there's a command. You need to be aware of few commands. Let's say Docker images will tell me the total images I have. So I don't have any images right now. So I can pull the image. So what is the command to pull the image? This is the link. So Docker pull HTTPD. I can issue this command. So Docker pull HTTPD. So I have pulling the image from hub.docker.com. By default, it pulls from there. You can also log in and you can have your repository. You can sign in. I have an account here. I have my own repository. I have pushed so many images here. Customize my images. So look at this. This is my image, and I have my so many repositories I have here. I can take one of the images from these repositories also. But right now, let me put it for pull one normal. Even you guys can do it. If you go to hub.docker.com, you can pull this image. Okay. So let's say I have pulled this. Good. Let's run this. So to run this, that's when it become container. To see the running containers, the command is docker ps or container ls. Docker container ls will give you the same output. But right now I don't have any container running, so it's no output. So let's run this. How to run this? Docker run is the command -itd. It's a web server. Understand one important thing. Very important thing you need to understand. It's a web server. And you're running as a container. Understand one thing. I'm going to draw it here itself. One very important point to understand. This is a VM. This is the VM. Okay, this is the VM, right? Let's take this example. I want to run web server as a container. Let me make this. This is the container I want to run. HTTPD container. Which container I want to run? I want to run HTTPD container. Web server. from Apache, HTTPD container I want to run. By default, this container runs on port 80. I can check it. I can do Docker inspect. One second, guys. I can do Docker inspect this image ID. Let's do this. Image ID, whatever image you have, what is the image ID? Let me display it. Let me type Docker images. So this is the image ID. So let's do Docker inspect image ID. So this will tell you where it is. Okay, let's do this. So I did Docker inspect image ID, and this is where you can just go over it, and you can see this exposed port is 80. In the image, they have this detail. When I inspect this image, I can see that this image is exposed on port 80. By default, the web server is default exposed on port 80 only. Good. So keep this thought, 80. So what does that mean for me? For me, it means that port 80 is where my container would run. Port 80 is where my container would run. Okay. Now, this is going to be a web server. Obviously, I would like to access this web server. Yes or no? Obviously, I would like to access this web server. What is the importance of web server if I cannot expose? If the external people, you and I, cannot access this web server, what is the point? But no, there is a catch. It is not directly on the VM. Else, I could have I can use public IP of the VM. I could have used public IP of the VM :80, and I could have accessed my application web server here. But I cannot use 80 here. I have the public IP of the VM, but can I use 80 here? Can I use this IP? No, because that is running as a container. That is the difference. So I have to do a port mapping. What I have to do? Port mapping I have to do. I have to create a bridge. I have to create a bridge between the container and the VM. That's called port mapping. I can mention that 82 port or 84 port or 85 port or 80 port or 80 port of the host maps to 80 port of the container. I can give any port, available port of the host which maps to the container. I can do that. Okay. So what is the command I will give? So just on the same thought, guys. Same thought. I'm going to run this. So I have the Docker images. And I'm going to run this. So Docker run -itd port mapping I have to do. Let's say 82 port of the host maps to 80 port of the container. That is fixed. I can give 83 also, 84 also, whatever port available. I can give that. So let's say 82 port. Now HTTPD is the image. That's all. If I hit this, my container would get created. I can type Docker PS. You can see the container running. And you can see the port, how the port is being mapped. Port mapping, we call it. So I can access the container on port 80. I can use the public IP of the host :82 to access the container which is running on port 80. Let's do that. So for that, I need to just open in the security group. I have to go to the EC2 instance. I hope some of you, if you guys know the basics of cloud, what I'm doing here. So let's go to the security group. I have to open this port. If not, I cannot. See, cloud is again a very important thing to learn. Okay, you want to exceed in your career. So you should know what am I doing. I'm just opening port 82. I can mention everyone. I can give everyone the access, save rule. If I do this, I can go to the instance. I can take the public IP of the VM. This is where my VM, I can access this VM, I can use this public IP, colon 82 port, not 80 port. I can access my application. Check this out. Is it working for you? What this is what everyone should get. I have allowed everyone the access. Are you getting this page? This is coming from my web server. Web container. I'm running as a container. Is it working for you, all of you? We'll see how this page is coming, where this page is coming from. Is it working for all of you? Quick confirmation, guys. I can restrict the traffic. I can restrict your access through security group. If I want, I can restrict your. Right now using security group, I can restrict your access. I can just give myself the access. Let me show you. So this is my public IP of my VM, my laptop. What I can do, I can go ahead and restrict this. If I don't want you to access this, that's the security group for you. I have given everyone access, but right now if I want, I can give only myself access. Now try to access, you will not be able to access. Okay? You will not be able to access now. Right. Sorry, wait for some time. I have given just reverse, okay? I should have done for this guy, not this guy. Now, guys, please try this and let me know. Can you guys access this? Try to refresh this incognito window. Try to access that in incognito window and tell me, are you able to open that page? You will not be, because I am controlling it. I have just restricted your permission. Only I can access this. In the entire world, only I can access this application, because that's the only IP I'm allowing. Is it working for you? Tell me yes or no. Not working. Yes, that's the security group for you. But right now, if I want, I can change it and I can give you permission. So that 82 port, even if I don't allow 82 port, even I cannot access this, because I have opened in port 82. So that's the firewall, right? So let me allow you guys. Now you guys will be able to access, because I have given everyone the access. Okay. So now let's understand one thing. So I have created a VM. I have created a container, Docker PS. That is the container, and I'm getting this page. It works. From where this page is coming? It works is my output, right? It works. There has to be somewhere this page. This page is coming from somewhere. This page. This page is in the container. Let me show you where this page is coming from. Docker exec is the command to go inside the container. -it. Sorry. Docker exec -it. Do this container ID. Bin bash. Do you see the difference between this line and this line? What do you guys think? Where am I right now? In the VM or in the container? Look at the difference between these two lines. Where am I right now? Do you guys see the difference here? I was in the VM and now I'm in the container. Yes or no? And this is coming, it works, is coming from this htdocs. If you go to htdocs, index.html. If I cat this index.html, this is where it works is coming from. If I change this index.html, if I change this, the output will be also changed. So I'm inside the container. What do you guys think? Which operating system I am in? Guys, tell me. What do you guys think? Which operating system I am in? Am I in the VM or in the container? I'm in the container, right? Someone asked this question. What's the difference? Look at the difference. I'm inside the container, but it feels like I'm in Linux operating system. Tell me one thing. If I type Docker version, will I get the output? I typed Docker version in the VM, I got the output because Docker was installed. Now tell me one thing. If I type Docker version, will I get the output here? What do you guys think? Remember, I typed Docker version. I'm exiting this. I'm in the VM right now. I type Docker version because I installed Docker. You see the output. Now, the moment I go to the container, if I type Docker version, will I get the output? I'm inside the container now. Will I get the output? I will not get the output. Yes, it is not installed. It's a different separate entity. Even VI is not installed. VI is not, I cannot do VI. I have to install Vim. Then only I can do VI. So it's an OS. It's a different world. It feels like you are in a VM, but you are not. You are inside the VM. You are inside a process inside a VM. That's container for you. It is using some resource. Exit. I can type Docker stats. This is using some resource. Look at this. CPU. This is the memory. It's being used by the container. Just like a process. I can go inside the container. I can have install web server, app server, database server. I can have a 3-tier application. Look at the footprint it has. In 1 GB, how much it has taken? 1 GB RAM. I can have my database server, app server both installed. Let me show you one thing. Let me install one operating system. Docker pull Fedora. I'm pulling one operating system, Fedora. I'm in the Ubuntu, which is Debian family. Okay, my bad. I am inside the SAPGUI. So I'm in the VM. If I do Docker images, I will see 2 images right now. Can you guys look at the size of the Fedora OS? What is the size of Fedora OS? Can you guys tell me the size of Fedora OS? Is it possible to have an operating system with this much size? That's container image for you because it is going to use the binaries and libraries of the host operating system, and it has the bare minimal binary and library which is the difference. So let me run this Fedora image to get a container. Docker run -it d. I don't need to do a port mapping. It's not a web server. I can directly do Fedora. Now if I do Docker ps, there will be 2 containers running. One is my web server, another one is my Fedora. I can do Docker stats. Look at the footprint of these 2 operating systems, these 2 containers. That's all. My Fedora is taking only so much. That's all. That is all. This is what Fedora is taking. Nothing. I can go inside the Fedora also. I can go inside the Fedora and trust me, apt command will not work because Fedora is CentOS. Yum command work. I'm inside a Ubuntu VM. I've created a Fedora container, Fedora OS container. I can go inside this Docker exit -it. Fedora bin bash. I am inside the Fedora container. Trust me, apt command will not work here. If I do apt update will not work here. But yum command will work here. So that proves that it's a different world. Apt command works here because Fedora is a CentOS family. Yum command works. I'm updating the packages. It uses the kernel, Vijay, it uses the kernel of the host operating system because it virtualizes the host OS, so it uses the kernel. It has the same OS. It uses the same kernel. But it's a different, it uses the binary libraries, but it's a different world. Don't think it's used the same. That's what I'm trying to show you the difference. I'm updating it. So that's container for you. Guys, did we understand the difference? The Docker and the containers. And the most important, containers are so lightweight. Performance wise, no problem. You get the URL, you can run it. So lightweight, it helps in cost reduction immensely. Portability, better performance. It boots up in seconds. I can just stop the container, start the container within a fraction. Takes fractions of disk and memory. Right? So there are so many commands is there for the Docker. You can allocate, if you want to allocate a dedicated CPU for a container, you can do that. Okay. So guys, I have talked about a lot of things. I talked about cloud. I showed you, I talked about microservices, Docker. So see, understand this. It's going to be very important. So guys, do you agree, first of all, do you agree that all these things that we're talking about, cloud, Docker, microservices are very important for a performance engineers nowadays? Okay, I'll not be able to share this document right now. Okay. Anyway, it's been recorded. I'll be sharing the recording. Okay. But if anyone is planning for a full course, guys, with me, okay. So I have a course, okay, with Isha Training Solutions. I have a course which I am planning from tomorrow. Okay. Tomorrow is the demo of that course where I'm going to talk about cloud. I'm going to talk about microservices, monolithic applications, Docker, Kubernetes. See, you can create containers. That's one thing. You can create containers. You have seen creating containers, but at the end, you want, for a performance engineer, what is important? You want containers to auto scale. When the load increases, you want containers to auto scale. Yes or no? You want auto scale. You want auto scaling of containers based on the load. If a container dies for any issues, you want self-healing. You want a new container to be created. You don't want downtime when you're deploying that. You don't want downtime. You want automated deployment. All these things will be provided by the container orchestration engine like Kubernetes. So we have Docker, which helps you to create containers. And then we have Kubernetes, which is the container orchestration engine, which gives you these features, auto scaling features. Half of the performance issues get resolved here. The scalability is not at all a concern nowadays. If you have auto scaling enabled, scalability is not a concern. Only thing what matters in the performance is that application is performing well or not. Do you have any issues, contention in the code? That what performance, but the scalability part, high availability part will be taken care by Kubernetes itself. So I am planning with a full course, guys, where I talk about a lot of things. It's a quite an exhaustive course. You can go over the demo. I can share this link with you, and you can join me tomorrow. I've shared the link with you. You can join with me tomorrow. Just it's going to be a demo, same time, 6 p.m. to 7 p.m. And where I talk about cloud computing, AWS. If you're very much new to AWS, I talked about SRE concepts. What is reliability, fault tolerance, high availability, monolithic applications, Docker, Kubernetes in detail. I just give you a demo today, but we're going to go in detail what it requires for a performance engineer. Gaining resilience. How can you gain resilience and reliability in AWS? Observability. We talk about a lot of tools. Linux monitoring, CloudWatch, Prometheus Grafana, ELK. I share a lot of Java performance engineering videos with you. Heap dump analysis, memory dump analysis, GC log analysis, performance concepts. I talk about automation. It's a complete course that I have. Shell scripting, and where we talk about sharing a lot of Java code and Python code. So guys, feel free to attend tomorrow's demo with me, and you can ask me more questions about the course. Having said this, do we have any questions so far with the course agenda with the workshop agenda that we have covered today? Any questions on the workshop agenda, guys? Feel free to ask me any question. Okay, did we understand things first of all? Did we understand, guys? Monolithic applications, microservices, how do we create microservices? How do we create containers? Docker container lifecycle. Did we understand this? I hope it was very much knowledgeful session for you. Okay, so we need to have that microservices understanding, guys, for every performance engineers. Any questions, guys? Feel free to ask any question. Okay, perfect, guys. No questions. We're good then. Thank you so much, guys. We'll be sharing the recording, and I hope to meet you tomorrow. Thank you.